we were talking about costs. This is the one of the hybrid trucks that's on the market. Parker's a multinational company that employs over 40,000 employees worldwide. Pretty much if anyone's got any kind of construction, on-road, off-road, anything that uses a pump, they're buying a piece of Parker technology, either in Aeroquick hoses, Chelsea pumps, or Parker switches and controls. This is their first entree into actually getting a control device that actually rotates the vehicles down the road. So they're very excited about it, but unlike a lot of private equity firms that I've worked for in the past, this is a huge multinational conglomerate, so they bring things to market slowly. I had another slide up here talking about the over 10 years of development of this product, and I left it out. I'm sure I'm going to have the shortest presentation. But this vehicle right here, we're talking about the cost, is upwards of $350,000. We have an exclusivity to market this product with the Parker company for the next 2 years, at which time I'm sure they'll have it available with a lot of the OEMs, Mack and Peterbilt and so forth. I wanted to start with just explaining, so I wasn't sure of the audience, what hybrid technology it does. And before I begin with that, I do believe in the hybrid technology. And once again, I don't represent Parker. I represent the other side, the make money side. And I think that going forward, either both electric and hydraulic hybrids are going to be a way of the future to overall being profitable, because not only do you want to, the regulations are going to continue to be about cutting your carbon footprint. It's going to be the new buzzwords going forward. Our previous speaker, Brad, was mentioning that. And the best way to cut your footprint is to reduce the overall fuel that you're burning. Reducing the gallons per hour that you burn, no matter what the fuel site is going to help reduce your footprint. And every fuel out there has some sort of carbon footprint, be it CNG, ethanol, B20, or diesel. And the nice thing about this technology, it just cuts your footprint by the minimum of this particular, it's a very successful product, by the way, by a minimum of a third to as much as 50%. That plus, we saw the prices of diesel, $5 a gallon. I don't think that we're going to see, $3 a gallon diesel again. The market's pretty depressed right now, and we're still above that. So, also reduce the amount of fuel that you're using. Obviously, increases your profitability. There are, in the test sale division, they had A, B, Alpha, Beta, Charlie, as they were developing the different products, and they have, I think they're up to 16 of these running in Miami-Dade, and over 10 of them have been on the road for over a year. So it's a relatively new product, but it's been very successful. This is just an example of how the technology works. This is your standard diesel engine that everybody's running today. It has an engine, transmission, a drive shaft, and a rear bogie. That transfer case, we'll call it a transfer case for today's. It has a torque converter energy loss with the transmission. So as you step on the throttle, all these gears wind up, and there's an actual lapse in the time that you get the power that you're trying to deliver, and it also decreases the amount of horsepower that's delivered to the transfer case going through the transmission. The next slide is the hydraulic launch assist technology. And this is out there by Eaton and Bosch have systems, and it's relatively successful. They go between 10 and 20% reduction in fuel. And what that is it's a parallel system. Actually, you should have 2 drive shafts to make it anatomically correct. But it's an engine, transmission, a drive shaft, and then the pump motor. And the reason why they're always called pump motors is because the way the technology works is as you it actually recovers the energy and then it disperses the energy to the rear transfer cage. And the way it works, the efficiencies come from your brake energy. As you spin up a drive line and you reduce the drive line speed by braking, there's energy that can be recaptured, and that's the regenerative braking energy. And when they recapture the energy, the pump pumps up these accumulators, and now you have a full accumulator full of oil, and the oil actually assists in this particular case, because there's a transmission, assists in driving the rear transfer case with that oil, and that's when the pump becomes a motor. I get everybody there? Okay. The next part of transmissions are out there is there's no transmission, there's just a pump motor. And so what happens when you use your engine to drive the motor and fill up the accumulators and throw the oil back here to the gearbox and the transfer case, and that's what powers the rear axle. And there's no energy savings in that. When you step on the brake, then it becomes once again a pump, and then that braking energy again is filling up the accumulators, and that's when you get a free launch. And that's a full hydraulic system. The problem with the full hydraulic system, they used to have a sweeper that was very popular in the South Bay going back a few years called the Sunstrand sweeper, and it was a totally hydrostatic drive like this. The hydrostatic drives, it's hard to get up into high speeds. Going over 30 miles an hour on pure hydrostatic drive means you're going to have to throw a lot of fluid back to the transfer case in a short amount of time with a little time to regenerate the amount of fluid that's on there. So to make it possible to go over 30 or 40 miles an hour, you have to either increase the size of these motors and pumps as well as how much fluid you have to regenerate. So it's not very practical if you're going to try an on-highway location, unless you're going to go low speeds like a sweeper. And okay. Thank you. And then this is the Parker system. It's like the hydrostatic drive. It has 3 gears. First gear is the regenerative braking gear. And it has a no transmission, but it does have a drive line. And the drive line goes all the way through. And in first gear, it works on braking regeneration. So you're either filling up the accumulators by the engine, or you're getting a free launch because you used your brake regeneration and you filled up the accumulators, and then you got launched for free by the hydraulic oil to the rear transfer case. The second gear is all hydrostatic. And that happens about 18 miles an hour and goes up to 40 miles an hour, or just under. Excuse me. That's second gear. You're not saving much fuel there. And it goes to about 40 miles an hour. And this is the interesting part of what they've developed at Parker, is in third gear at 40 miles an hour, this entire system clutches out. And then you're in what's called direct drive. So you've cut out all the hydrostatic capabilities of the truck, and you're just running like a regular diesel truck down the road. I guess, so you're saying, so what? And the so what is that in Florida they've saved up to 56% on route. I will say that what I do know about Parker is they also have this in a bus situation that's on test, and they also have it in a FedEx delivery truck. You need a lot of stops, obviously, for this. In the bus situation, they have the engine off capability. So if you pull up to a stop, you're going to be there for probably less than a minute, but during that minute, your engine's off. Now you pulled up to the stop, you filled up your accumulators. So as everybody gets on, they've paid their fares, they sit down, the bus takes off. It takes off for free with the launch that it used on its braking. And then during the launch, the engine comes back on. Then when you need the demand of the engine takes you to the next stop. So once again, I really believe in the technology. I think that the hybrid technology is going to be there. I was talking with a guy from I don't know, but lately I've been seeing you go on a lot of these panel discussions. And I feel myself ineptly unqualified to be up here, but I do sell a lot of trucks. Anyway, guy from Chrysler was there, and he's putting the hydraulic option on their vans. Now they go up, they're kind of like Parker, they're talking about 2013, 14, 15, having that availability. And I said, well, why? You know, they're tough to package, they're expensive, they're kind of cumbersome. And he says, hey, you know, we all have to reduce the amount of fuel that we're doing. I don't think the fuel's going to go down. And with everyone going that direction, the only true high GVW option that's out there is hydraulic. There's a lot of electric that I believe in too, and I think that you're seeing that packaging a lot with the cars. But I think hybrid is neat technology because, like I said, it's going to work with anything. I mean, ultimately it takes a little bit of R&D to get past, okay, I want to put, but we've already burned V20 in this, and we've burned diesel, and we've got an engine from Cummins to do CNG or LNG. I think we're going to first package CNG. The next slide is what. Okay, let's just go like that. You know, the important part about this slide is let's just work with the 30% or 35%. If you're dealing with a baseline and you're burning 50 gallons a day, which is unusual with, you know, I can speak to just the two industries I work in. So that's going to, you know, make 138.75 tons per year of CO2. If you save 35% of that, you're going to, which is, you know, reducing your usage from gallons per, well, reducing fuel reduction of 3,750 gallons per year, and it has a total of reduction of 41 plus tons per year per vehicle. And I think that's the most powerful part of that slide.
Batteries left.
There it is. Okay. It's operator here.
No.
Okay, so oh yeah, they're working with the EPA. Parker is, and that's what this slide's about. And apparently you have to be on some list, and they're going forward with becoming part of the certified for the EPA. Some EPA guy was down in Miami, and he looked at all their numbers, and he got very excited about the technology. The neatest thing about this thing when you're out there running it is you take your baseline vehicle and you look at their routes that they were doing, and then you go and run the route, you know, any ones that they pick, and I haven't had less than 30% savings. Up to 50% savings, depending on the route that was done. So it's kind of neat to be on the forefront and part of a technology that really works, because I've been on the other end of that where, you know, it looks good in the shop and looks good on the engineering, and you take it out there and it fails or doesn't, you know, meet the same results. I have a real high degree of confidence that anybody I sell this truck to after demoing it for just 3 weeks, that it will deliver the results that it's promised of anywhere between 30 and 50% fuel savings.